All right, so what we want to do here is we want to demonstrate some of the equipment that we have, and this is similar but not identical to the equipment that you have in your Amazon goodie bag. Okay, so here we have our battery holders. Here we have our resistor that we're going to use. Here we have our multimeter, my handy dandy pencil, and we have some batteries over here, and we have one of our gator clips here that we're going to use to complete the circuit, and my data sheet here as well. Now the first thing is you should watch the introduction to the multimeter on the other YouTube video that we've posted, but here is the multimeter that we're going to use. And if you watch the other video, you'll see that there are several ports here, all right? Now your black cord, all right, should always act as your ground. In some case, it says the COM, okay? So this is the common port, all right? But over here, we have the voltage and the resistance symbol. So if I want to measure voltages or resistances, I want my red lead to go into that port, but if I want to measure currents, then I need to use one of these two ports. Mainly, you're going to use the 200 milliamps. We're not really going to be working with high amperage in this class, okay? So I want to keep that black port plugged in, right? And the first thing I'm going to do, you don't have to do this step because your resistances are going to have been, they have a value stated on them, right? Or at least on the package that they came in. There's going to be a value for their resistance that's stated. But I'm going to measure the resistance of this resistor, and I'm going to do that by putting it on the resistor setting. And I know that this is less than 200 ohms, so I've got it on the 200 ohm setting. If this resistor were higher than 200 ohms, the ammeter would give me an error, or the multimeter would give me an error. But it looks like it is 150.8. So I'm going to go ahead and record that on my sheet here, 150.8, okay? Now we're actually ready to build the circuit. And notice that in my battery pack, I've only got one resistor in here so far. Whoops, while I keep these connected. And what I'm going to do is, your battery pack, it really shouldn't matter what order the batteries are put in, just as long as they're put in the right way, all right? It shouldn't matter all that much what order they're put in. Now, for our circuit, right, what we're going to do is we're going to untangle this first, all right? And what we need to do is make a complete loop with our resistor, voltage source, and ammeter. So I'm going to hook this gator clip to one side of my battery pack, and then I'm going to hook the other side of the gator clip to the resistor, and then I'm going to hook one side of the multimeter to the resistor, and then I'm going to let this other side of my multimeter act as my probe. Now, when I only have one battery in one of these packs, I'm going to actually have to touch. You shouldn't have to do this, but I'm actually going to have to touch the bottom of the battery, okay? But we're actually ready to start taking measurements, and so I've got my cord in the correct port, and I'm going to turn this down to the milliamp range, okay? Here's 200 milliamps, 20 milliamps, 2 milliamps, 200 microamps, all right? And this should give us some readings. Now, these are going to be in milliamps, and you're going to want to convert your measurements to amps, but when I complete the circuit by touching the negative lead or the ground lead on the multimeter to the negative terminal of the battery, first things first, notice, okay, notice that we have one complete loop here, okay? So even though it looks kind of wonky, right, it is just one complete loop. It's just a simple loop. And it's giving us a value of 9.6 milliamps, and 9.6 milliamps is 0.0096 amps. So that's what I'm going to record on my sheet. 0.0096 milliamps, or I'm sorry, 0.0096 amps. And now I'm going to add another battery. So I'm going to double the voltage, and you do want to make sure you're putting your batteries in the correct way, the correct orientation. And doing that, all I have to do now is clamp my lead down to the battery holder, and I get 19.04 milliamps. And I'm going to round that to 19 milliamps. So I'm going to record 0.0191 amps. 0.0191 amps. Okay, so I'm rounding that up. All right, I'm going to take another battery and put that in there. And then I'm going to put my... Now you'll notice that this is now a 1. Since this is a 1, what I have to do is adjust the scale here. This is telling me that there's too much current for that particular setting. And when I change it up to the 200 milliamp setting, now it will read anything below 200 milliamps, and I'm getting 30.1. So again, this is in milliamps. So in terms of amps, that's 0.0301. 0.0301. And I'm going to add another battery. And so we just do this, right? We just do this and record our data. So now we get 40.1 milliamps, or 0.04. Now, and don't worry about it if the last number bounces around a little bit, okay? Just take the average, or one of the two if you prefer, because that last decimal point is really not going to matter all that much. So you can get away no problem with recording 40 milliamps here. So 0.0400 milliamps, or amps rather. Okay, and so we're going to put in our next battery, and we're going to read that 49.9, 49.8. We'll leave it at 49.9. So 0.0499 amps. I'm going to bring my batteries in from over here. And we're going to do a couple more measurements. 59.6, it looks like. So 0.0596 amps. And two more, right? And here we're going to get 69.1. So 0.0691. And we'll add the last battery. All right, we will add the last battery. And here we go. All right. So our final current measurement is going to be 78.9, so 0.0789. Okay, so I have completed my table here. All right, I've completed the table, and what I'm going to do here in a moment, I'll demonstrate this for you, is I'm going to plot my voltages and my currents. But what I'm going to do is I'm going to put my voltage on the y-axis and my current on the x-axis, okay? And that is going to allow me to demonstrate Ohm's law with this system. You can do it the other way, and in fact, the other way is the more proper way to do it experimentally. In this particular kind of experiment, my voltage is acting as my independent variable, the current is acting as the dependent variable, and typically we label the independent variable on the x-axis and the dependent variable on the y-axis, but the way Ohm's law is structured, we're going to put this on the y-axis and the current on the x-axis. Now, you'll notice, okay, this resistor column, this V across the resistor. So what we're doing is we're assuming that each of these batteries is exactly 1.5 volts. And in the first chart that I wanted you to plot, this one right here, voltage using the batteries as your voltage, this column right here, I want you to put that plot right here, okay? So copy and paste in the Word document and input your chart here. But something else that we can do is actually use our multimeter and remove a battery at a time and measure the voltage across the resistor, okay? So what I'm gonna do, that's actually getting pretty hot. So I'm gonna let this cool down for a minute. And so what I'm gonna do is I am going to just simply take this out. I'm gonna put this in. Now, this is the most crucial step with the multimeters, okay? When you're getting ready to measure voltages, be sure to change your input, okay? It won't damage the multimeter if you accidentally measure currents with the voltage setting, but it will absolutely damage the multimeter if you accidentally measure voltages on the amperage setting, right? So what we're gonna do is take the multimeter out, and now I just have this, all right? I just have this. And so my current should be flowing, and what I'm gonna do is I'm gonna set this to the voltage setting, all right? And I'm going to put my multimeter across the resistor. All right, I'm going to put my multimeter across the resistor. Now notice, it's not exactly 12 volts. It's 11.9, right? So technically, Ohm's law, V equals IR, states that it is the voltage that goes across a resistor that is equal to the resistor's current times its resistance. So actually what's happening is we should be measuring this amperage, or this voltage as a matter of fact. So in this resistor column, the V across the resistor, I'm going to record this voltage. So 11.88. All right. And now what I'm going to do is I'm going to unhook the circuit, and I'm going to remove one of the batteries, all right? And then I'm going to complete the circuit again. And you'll notice that it gives me a voltage of 10.43. Oops, and this needs to be at the top because that was our 12 volts. So this was 11.88 and this was 10.43. Now it's 10.45, that's fine. So 10.45, right, and then take that battery out. And so now we're measuring 8.99. And if I take a battery out, I'm now going to measure 7.52. And if I take another battery out, I'm going to measure 6.03. Take another battery out, and I'm going to measure 4.54. All right, take another battery out. I'm going to measure 3.04. And take the last battery out, and I've got 1.52. Okay, so now I've got that table also filled in, okay? So what I want you to do in this plot is, in this area, is generate this plot, and then in this area generate that plot. These currents and voltages, and in this area, these currents and these voltages, okay? And the idea is your batteries are stated to be 1.5 volts, and that's all well and good, but they're actually not exactly 1.5 volts. So what should happen is this should actually give you a slightly cleaner linear trend, okay? It should actually be slightly cleaner. Now, are either of these going to be perfect linear trends? No, but they should be very good, okay? These should be really good linear trends, and here in just a moment I will show you what I want you to do with this data. All right.